Hello, good afternoon. My name is Christian Blaschke from the Semantic Web Company in Vienna. I'm happy to have here with me now Dr. Stasinos Konstantopoulos from Athens, from the NCSR Demokritos in Athens in Greece. He's a specialist he's a computer scientist and he's a specialist in machine learning logic and semantic web technologies and language engineering. And most importantly, he's one of the main participants in the Powder working group, contributing to the logical foundations of the Powder formalism. The talk today will be about the Powder protocol, which is a W3C recommendation for publishing metadata about web resources. And the talk will be first an introduction about Powder, providing some brief overview about the syntax and semantics, and then there will be use cases and actual deployments. The reason why we are here together is because we're happy to work with Stasinos together in a research project, in a STRAP project, which started in November last year, which is called SemaGrow, which you also see on the slides here. And SemaGrow is about large-scale deployment of semantic data. Here there's a clear trend to open up data and to provide the data on the internet more and more. And now we need to, or people want to seize this opportunity to add some value to this data, because just having the data and not integrating it, not using it together, will not break up, will not open up these silos. They will just stay silos as they were before. So SemaGrow envisions to create, to develop a scalable, efficient, and robust infrastructure to federate data in a flexible and robust way, so that it can welcome in new data sources, that the data models can be adapted or integrated flexibly and on the level of the integration stack, so without changing anything of the underlying data. And so this project started in November 2012. It will go to run for three years until 2015. It's, as I said, it's a STRAP, a European research project, and it's coordinated at the University of Alcalá. There are 8 participants in this project. One, as I said, is the University of Alcalá coordinating, then NCSR Demokritos in Athens, then we ourselves, the Semantic Web Company in Vienna, another SME in Athens, and some other partners, like I would like to mention the FAO, the Food and Agricultural Organization in Italy. And a little bit about ourselves. So we are an SME in Vienna, and we have been around for more than 10 years. We are a team of experts in the area of content management, semantic technologies, text mining, and linked data. And we've been working around what we call smart content solutions and linked data management. And without further ado, I give over to our colleague, and I hope you will all enjoy, as we do, or will certainly, his presence and the talk. Thank you.
Thank you, Christian. So I think we've covered this first slide and can move on to a very brief introduction to the protocol for web description resources, Powder. And what Powder is about is serving metadata about web resources. And Powder is a follow-up to some of these, or general akin to PICS, which is a precursor to RDF, the labeling protocol by W3C, and then the RDF aboutEach prefix vocabulary item that was dropped from later versions of RDF, and as simple formats as robots.txt. So what's about is mostly about telling us where, in which part of a website something is, or what kinds of resources are in different parts of a website. So that's that's the most straightforward and simple way to define the scope and objectives of a Powder protocol. So a Powder document is made up of description resources, and a description resource, a DR, is a basic information unit, and it has two parts, the URI set and the descriptor set. And the URI set is a specification of a set of resources, set of URIs. And well, I'm going to be using URI and URI interchangeably throughout this talk. I don't think I can manage to always say URI. But it's a specification of a set of URIs and a description. So a description is properties and their values. And what is meant to mean is that every resource that has a URI that is consistent with its specification should have these properties and property values conferred upon it. So the descriptor set can have both object and data type properties. So we can say that something is red and something is square, and red can be just a string property, and square can be taken from an RDF vocabulary. And there is also so there is this mechanism for using any property, but there's also some elements in the XML format of Powder documents that are special, like type-of, which is used to give the RDF type property, and display text and display icon, which are meant to give a human readable text and human understandable depiction of a particular property. So if something we say is red and square, then we can have some icon that represents it, and that's going to come in handy when we need to have a very concise representation of the properties conferred to a resource. So then the URI set, like I said, is everything okay? Okay, so the URI set is a specification of a set of resources, and there's several elements defined, like include hosts, which is, and they're pretty much self-explanatory, right? So include hosts, everything that is the text of this element is hosts in the URLs where the hosts portion of the URL matches, and path starts with, and so on. And the names of the elements are pretty much self-explanatory. You can have both include and exclude elements. So everything that is under example.com and is not in a directory that starts with square, for example, it would be include hosts example.com and exclude path starts with square. And then you can also have patterns. This is like Unix global patterns. Just star.example.com is all the subdomains of example.com. And there is also, this can also be combined, so there can be more than one URI sets, and then the semantics of these more complex specifications is that if there is multiple values within an element, then it's sufficient on any one satisfied. So either example.com or example.net in the example at the top. And if there is multiple include whatever or exclude whatever elements in an URI set, then they must all be satisfied. So here something must be in example.com and under the path red/square. And if there is multiple URI sets, then it's sufficient that one of them is satisfied. So you can use this to build up any exclusion or inclusion pattern one needs, and exclude subdirectories, but then describe multiple websites that have similar structure and so on. But what it all boils down to is regular expressions over URIs. So all the different ways to describe portions of a website that we saw before, they can all be rewritten or translated into regular expressions, and they're all just convenience methods really. And the one specification that matters is the include exclude regular expression one. So This is a more flexible one, and there any regular expression can be used to describe any pattern over URLs. And then the semantics of this is that any URL that matches this regular expression has the properties described in the descriptor set of the DR. So we've seen what a single DR is. Then a powder document combines multiple DRs, and if there are an unordered list of DRs, like the ones right under the attribution block, then they must all be applied. If there is an ordered list of DRs, like the ones at the bottom of this document, then they get first match wins semantics. And then provenance and validity period and similar metadata regarding the whole document can be given in the attribution block. So now, like I mentioned before, it is important to note how all these different URI grouping mechanisms can all be reduced to a regular expression. And we have, excuse me. So we have defined the powder base as the basic, the most basic specification for powder documents, where the only URI grouping mechanism allowed is include regular expression and exclude regular expression. So there is the working group, the powder working group, has also worked out an XSLT transformation that can take us from powder to powder base, and this is a formal definition of what the powder elements mean. The URI grouping elements mean, right? So they are defined in terms of a transformation to a regular expression, and these are all very. These are described in more detail in the recommendation documents, and there is also publicly available XSLT script that anybody can use. So now the powder-based semantics in their turn are also defined in terms of RDF documents, and then the DRs can be reduced to a subsumption of the URI set under the descriptor set. So then, if we say that this grouping of resources is a subclass of a descriptor set, then they are all descriptor sets are the OWL class of all the things that have a given property and property value, like we see on the example on the right. So then subsuming IRI sets under descriptor sets means that they get all the members of the IRI set will have these properties and property values. So this is how I have formally defined the semantics of a DR, right? Of the fact that of a set of resources described by the URI set has the properties defined in the descriptor set. So that leaves us with a problem of assigning formal semantics to the grouping elements and the regular expression grouping element of the IRI. And this is the one bit that falls off the edge of RDF semantics. And it's easy to see how one cannot really define any set of resources based on the URI in standard RDF. So what we needed was an extension of RDF semantics that was the WDRS matches regex property that you see on the example on the right. So we defined this property as a property that links resources with regular expression strings such that the resources have a URL that matches the regular expression that is the filler of this property. And this is more rigidly defined in the formal semantics, but the essence is that this is a property between resources, named resources, so not blank nodes obviously, but named resources that and all regular expression that matches the name of these resources, the URL of these resources. And this extension of RDF semantics is what we call the powder S. So using this property, then we can assign formal semantics to IRI sets, as we see in this example. And again, there is an XSLT transformation worked out by the working group, which receives as input the powder-based XML documents, and the result is RDF documents using the WDRS matches regex property. So we see here how we have built the powder specification as this hierarchy of increasingly specific specifications. At the bottom, having a powder S, which is an extension, the extension of RDF semantics, where the WDRS matches regex property is defined. And then we use that to assign formal semantics to powder-based documents, which is XML documents that use include or exclude regular expression URI groups, URI grouping, the URI grouping mechanism, but only the regular expression ones. And then, based on powder base, we provided the formal definitions for all the grouping elements in powder. They include hosts and include ports and all these more convenient mechanisms for grouping URIs. So, given a powder document, what is a powder processor? What is a powder processor expected to do? It should have access, given access to one or more powder documents. It should respond with property values for URLs that it receives as input. And there is no requirement in the specification that powder processor carries out all these transformations, so that there is no requirement that it transforms powder documents into powder-based documents and then powder S documents, and then carries out actual semantic inference in order to decide if a given resource has a given property. But if it knows about the grouping mechanisms that the powder document is using, then it can apply them directly. So a powder processor that is knowledgeable about the include hosts, for example, extension, can apply it directly. If it is not, then it should use the formal XSLT transform to turn it into powder base and then process that, or powder S. And powder processor may directly process the XML formats, so powder or powder base, or it may implement a powder S extension and then use semantic inference in order to decide if the input URI has a given property and property value. So where do powder documents live? Anybody can publish a powder document describing resources that are outside their domain, and actually this is one of the use cases that we have foreseen for powder, that they would be one could also not only annotate their own resources but also annotate third-party resources. And so web resources can claim being covered by a given powder document using either RDFA or the link rel described by. And actually the described by property was one of the major outcomes of the working group, and its scope has gone beyond powder documents, and there has been actual uses of the described by property outside the context of a powder document. But it was originally meant to be a property that links a web resource to a powder document that describes it. Of course, this is a claim made by the author of the document, and then it also needs to be supported by the IRI sets in the powder document. And then the other thing that we felt that was one of the strong points of powder was its extendibility. So we saw how the the grouping mechanisms that are relevant to the resolvable web, so to hosts and ports and paths, we didn't hardwire them, but we developed them as extensions of the powder base specification. But anyone can derive further such grouping mechanisms and define them using, again, XSLT transformations in order to more concisely describe their own data, their own website. So, for example, if we can imagine a website that uses UK postcodes, like we see here in the example, then it might be a good idea to define a new document type. So let's call it GeoPowder here. That is defined as a powder document with more grouping mechanisms, such as include postcode starts with. And then one needs to have a regular expression that can transform include postcode starts with to path elements or to path elements in the powder grouping mechanisms, or even directly to powder-based regular expressions. So then one can use these more convenient grouping mechanisms that are specific to the way that a given site is organized, and express mappings, for example, to geonames here, or other annotations of their website in a more concise way than if they didn't have the ability to define this site-specific grouping elements, like include postcode starts with. So we see how we can make more specific powder formats from the basic powder format that mostly addresses the resolvable web. But powder is not restricted to that. So any structured identifiers, such as ISBN numbers, can also be used. Grouping elements specific to any kind of structured identifiers, such as ISBNs, can be defined, and they don't have to be related to URLs and to host names, right? So then we can define extensions directly from the powder base document specification, which only has the include regular expression grouping element. So implementations and deployments. So during the working group's lifetime, there have been 3 reference implementations. There were 2 powder processors, which directly processed XML documents without making the transforms to powder base or powder S. And there was also a powder S processor, which was developed as a module that that encapsulated the powder store, and whenever applicable, it asserted the matrix regex property, and then used semantic inference in order to actually directly implement the powder S semantics as described in the formal semantics of the powder specification. So these 3 are all available from the working group's website. And then there was a European project, Quattro Plus, which was pursuing a content labeling, child safety, or also medical content, whether it was appropriate or not, but labeling use case, where there was a powder document server deployed, and browser plugins that would look up on powder documents in order to confer appropriateness annotations on websites, and then the browser would use the display text or display icon properties in powder documents in order to visually depict appropriateness or inappropriateness annotations. So the Quattro Plus project, so all the host of tools that the Quattro project developed are also available from that website, and they have been deployed and actively used for the duration of the project, at least. Now, later on, during the Sync3 project, a new way to use Powder, a new idea was born about using Powder, and this goes to prove the versatility of the specification, and that this way of using Powder was not imagined. Nobody had thought of this during the actual working group, and the idea only came later. So Sync3 is a project on a large-scale indexing of news items. So it crawls blogs with news items and also newspapers sites and forums, and it indexes news content based on events mentioned and also persons and organizations mentioned. So it's based on an extensive gazetteer, and which is internally served as REST to the rest of the components of the system. And then there is a systematic naming convention for the things in the world. So persons are given an ID under a URL that has the string person inside, and then organizations the same, and place names and events mentioned. So it is obvious to tell by just looking at the URL at least the RDF type of all these instances. So the idea then was to use a Powder processor to infer this RDF type triples as an internal compression mechanism. So this is not meant to be published. These are project internal web services, and they're not exposed to the end user. But they did the way that the URLs were constructed and the way that these web services were deployed, they provide an opportunity for compression, and then the results of this so this RDF type triples that resulted from the Powder processor would also participate together with other asserted triples in RDFS inference. And there is no simplicity there because it is in the formal semantics of Powder that Powder inference can only take into account the URI patterns over the URIs itself and no other properties. So you can never use Powder to say things like, if a resource has a URI that matches this regular expression and it is also of RDF type char, then something else holds. This is not allowed. So the only antecedents for Powder inference is the URI itself. So it can be nicely layered under semantic inference. So we tried two different implementations there. One, both in using the OpenRDF Sesame infrastructure, and the Powder sale one is one that encapsulates the native store, the asserted triples store, and it makes Powder inferred triples available to RDFS inference. And in another alternative implementation, we developed a combined RDFS and Powder inference layer, where the rules of RDFS inference were augmented with Powder inference rules. And the combined RDFS and Powder inferred triples were served then to the client application. So for that particular application, for that particular dataset, the RDF type triples that we didn't need to make explicit anymore because they were inferred from the Powder annotations. made up 13% of the overall data. And in the PStore implementation, they gave an 18% speed up, as you can see in this table. So it's the speed up is bigger than what you would get just because you have shorter indexes. And this is not a result that is overwhelmingly faster, but it shows potential. And what needs to be noted is that the powder cell was implemented as simply as a filter clauses that would try to apply the regular expression. They would try to apply the regular expression to each and every resource in the store that matched the other fragments in the other patterns in the query. So when a query was posed to the store, then on the relational part of the query, all the relational query patterns would be applied first, and then all the matching for all the matching resources, their URLs would be retrieved and tried against the regular expressions in the powder documents in order to see which matched, and then infer the remaining properties, the properties that the powder documents, the descriptor sets described. So this is not the most efficient way of implementing powder, but still we would get some results. So like I said, this showed that there is potential in this approach of repurposing to some effect powder in order to achieve compression. So coming to the Semagro project, now we thought that we should try a direct implementation of the PStore. So not as a layer over a normal triple store, but directly implementing a triple store that is able to retrieve resources that match a given regular expression. Right? So we want a regular expression index that does not post-filter the relational parts of a query, but that directly looks for all resources that match a given regular expression. So that then we can have an efficient implementation of a WTRS matches regex property, and then we can use that as the basis for building powder S and then powder triple store. And in general, this would be a more efficient way of implementing powder with any application powder might have, but specifically for the Semagro project that this activity is part of, we are thinking that this would be a nice way to exploit regularities in resource naming conventions and the way that the URLs are constructed in order to have an index that can tell us for a given URL metadata that can take us from a given URL to the source or the store where further properties can be found. So we're imagining a situation where we have a large-scale Sparkle endpoint federation, and we need a way to figure out which of the sources that are federated are more likely to contain properties of a given resource. And all we know about this resource is its URL. So then powder is a very natural way to express the knowledge that, for example, that given a URI that matches a given regular expression, then we can directly go to the source that we know has properties of these kinds of URIs without having to either flood the federation with queries to every source or to keep separate indexes for this. So in the bottom line, we can say that URIs are in principle used as meaningless labels in RDF, and it is one of and it is this maxim, let's say, that a powder is challenging. And because URIs might be meaningless labels, but people tend to organize data in tree structures, and then also there's guidelines about URI design that also support the assumptions made by Powder. And several large-scale repositories also employ systematic naming conventions, like we saw in the Sync3 use case. And Powder is an opportunity to formalize and to have a formal way of actually expressing the knowledge that every URI that matches a given regular expression stands for resources that have a given property. And we can use this to mass annotate whole parts of a web resource, of a website, or we can capture the intention behind the structure, behind a database or open data information structure, or we can use it internally as in Semagrow or Sync3 as an index that can take us from URIs to sources where further properties can be looked up in a federation or in large scale repository. And I'll be happy to take questions. And I want to note that the presentation was prepared with the help of Phil Archer, who was the head of the working group when it was during its time with the W3C, and is now a W3C team member. And thanks for your attention. You need to.
Okay, Stasinos, thanks a lot. I'm not sure if I see the questions here or if there are no at this moment. I have actually one. So, I mean, I think at least in the RDF world, we are often describing data, RDF data sets using void or ADMS, and I'm not sure if you could elaborate a little bit about what Powder, for example, could do different, or why one would use Powder to add a description than using these other vocabularies.
Thank you. So one might very well use ADMS vocabularies to describe what kinds of information or properties about what kinds of resources are in a source, in a data source. But ADMS, but Powder can be used to work in the opposite direction. So given a resource's name, to tell us where to look up for further properties. So ADMS is more like a metadata about a source. And even if that metadata includes information such as the types of the things that are described in this resource, it won't help us in a situation where all we have is a URL. And in order to figure out the type of that URL, we need to have a source to run a query to in the first place. Right? So Powder can tell us something about this URL, its type or other properties, without having to guess where to query. So in the Semagrow case, for example, we could have multiple repositories, and one or two or some of them would have relevant properties. And if we're giving a URI in a query, then there is no way to even know its type before we have actually queried the repository that knows about this URI. And that's the kind of situation where Powder can come in. And by just looking at the URI, it can formalize the knowledge that one can get out of just looking at the URI, then can make educated guesses about, for example, which sources might be appropriate to ask. And then these sources might very well be described using ADMS, for example. But there's nothing in Powder that says that one can or cannot use any given vocabulary. Right? What is the essence of Powder is that you can get some properties regarding a resource by just looking at the URL, and there's nothing in Powder about which vocabulary you're going to use.
Okay, thanks. I'll hand over to another colleague here.
Okay, we have heard that WDRS, described by, is used also outside the context of Powder. For example, a resource can be annotated with is described by, and then you use a FOF document. How do you distinguish the Powder description from a FOF document? Is there an own MIME type?
Yeah, in the case of linkrel, yeah, there's a MIME type. There's a MIME type registered. I don't remember exactly what WDR sounds like a good candidate, but I don't quite remember if you can look it up in the registry. But yes, we have gone through the loops of getting a Powder document type. And also, if it's an RDF, if it's the RDF property described by, then there is a WDR document type defined by the Powder specification. But the linkrel filler is the XML document. Yes. More?
Yeah, one more short question. Can you give us an example of how to get the most out of a URI? Can you maybe shed some light on how to choose a URI pattern that is really suitable for Powder index?
Well, that's a very, yeah, in the most general way, no, not really. So, in general, we don't want to actually provide any guidelines about how to structure one's URIs, and that's not really necessary because people tend to organize URIs following just the normal guidelines, like oh, can I never go back? Like cool URIs or any other URI guidelines is going to be already putting information into the URI. And then you see how in the Sync3 case, it came naturally that the different REST services describe, hold instances of a different type. And in general, just observing the way that the information is structured is going to give you enough hints about where to look for things that can be an RDF type or a similar semantic property. So we don't really have specific guidelines that you should structure your URLs like that, but the way people tend to structure URLs is usually going to give some Powder inferred documents. Now, if you think of it only in terms of compression, then the amount of compression one is going to achieve will vary depending on the repository. But what is important to remember is that you shouldn't really think of it as compression in the conventional sense, because what it really captures is the intention. So it's not only something about all the resources that are there now, but it's also a statement about all the resources that are there now and will be added in the future, right? So when the Sync3 web services were established, it was obvious that in the future as well, everything under the Sync3 u/blah blah /organization URL is always going to be an organization resource. And so it's not just that you can compress, let's say, the data that's there now, but it's a way to describe the organization of the website as a whole. And it can be used also in the opposite direction for resource discovery. So when somebody wants to look for persons or organizations, then you can use the powder descriptions to figure out where to look for such instances.
Okay, Stasinos, thanks a lot. I think I don't see any more questions. So thank you for your talk, and well, hope the Semacro will will make a lot of use of that, and this is I think this will be one of the fundamental parts of the Semacro stack actually. Okay, so I think we will close this webinar here. I also would like to thank our colleagues Thomas Turner here that helped us set up this meeting and took care of advertising it and taking on the technical part. Okay, thank you. I think that's it for today.